Hi, I'm Fadi from ABBYY Ukraine, and I'm going to introduce you the basics of ABBYY FlexiLayout Studio. So, what is a ABBYY FlexiLayout Studio? First of all, it's a part of FlexiCapture solution. It's a software application that allows you to create a formalized description flex layouts of a document with a variable layouts. The created flex layouts are then used by form processing applications to capture data from the documents. Simply, you can create an application that can automatically process different types of the documents. So for this presentation, I expect that you already know the brief information about the FlexiCapture. Here I will discover you the basic concepts of capturing data from semi-structured and unstructured documents. Also explain the logic of creating FlexiLayout, formal descriptions that enable FlexiLayout Studio to find data in semi-structured and unstructured documents. Additionally, some methods of debugging and fine-tuning FlexiLayouts will be also described. Before we start, there is essential information regarding the documents we are going to process. For a data capture system to be able to capture data from a document, it must know what data to capture and where it can find them on the document. The documents could be classified in two types, structured and semi-structured. In other words, fixed and flexible forms. This classification is based on the way how to find the new fields. In the case of structured documents, specifying the position of data fields is relatively easy, as the fields containing the same type of data will be printed in exactly the same place on each copy. But most of the documents have no fixed data structure as the structured documents. They are the documents with a flexible or floating structure of data. And maybe the most popular example of semi-structured documents are invoices. Invoices usually have similar fields with similar types of data. However, the positions of the fields are not rigidly fixed. The useful data is placed differently, have relative fields captions to other fields. And the size of the fields may also vary. So, most of the fields have captions that indicate what type of information is placed in each field. And besides the data must be extracted, invoices may contain all sorts of other information, such as company logos, commands, or additional instructions. So, ABBYY's FlexiLayout technology allows to create a formalized description which tells the data capture program how and where to find particular fields. To create a FlexiLayout in ABBYY FlexiLayout Studio, first we need to create a project. Technically, a project is a set of files related to one particular FlexiLayout. These files store all relevant information about the particular type of the document. The information which enables the program to identify this particular type of document, descriptions of the data to be captured, and search criteria to be used. All work in FlexiLayout is done within a project. Projects fall into following two types. First, FlexiLayout projects. These projects are used to develop FlexiLayout to detect data fields on the document. And classifier project. These projects are used to develop classifiers to group document into classes. Within projects, FlexiLayouts and classifiers are built, tested, and debugged. A project includes the descriptions of the elements, a FlexiLayout or classifier, and the batch of images based on which the FlexiLayout is created and debugged. Here I will explain you the most essential thing about the FlexiLayout understanding, actually the basics. So, in the graphical interface, FlexiLayout is a tree-like structure with the branches of blocks and elements. What are the blocks and what are elements? A block in the region on the document image from which data should be captured. All the blocks in the FlexiLayout are absolutely the same as document definition fields from from which we need to extract the data. Each block stores information about the type of data in the corresponding region of the document and about the region itself. A region can be defined by stating its coordinates or by reference to the region of an element. To sum up, the main purpose of creating FlexiLayout is to define the regions with the data. And the elements. Elements correspond to one or more objects on the document image. So it could be text strings, pictures, barcodes, black lines, etc. Each element stores information about the type of the corresponding object, its properties, and the search area where to look for the object. And the elements are logically connected. When the program applies the FlexiLayout to a document, first it analyzes the image and then look for the document objects, which are described by FlexiLayout elements. So it do it sequentially, one by one, from the top of the tree. In other words, elements which are higher in the tree can be used to detect the elements which are lower in the hierarchy. For instance, the position of the field contents can be described relative to the caption of the field. And as a result, the program identifies the certain area around each found element object. These areas can be used to locate the block regions. As a sample, let's look at this picture. In the top, we can see the FlexiLayout name invoices. The blocks are the fields we need to extract: the invoice number, date, address, and for invoice number we have two related elements which correspond to the objects on the image. To understand how the FlexiLayout finds needed elements, let us see how humans find necessary data on the documents they have never seen before. Suppose we need to find the number of invoices shown down on the slide. A human will think approximately like this. First, apparently, the fields in this document have captions. Since the fields have captions, we must find the caption that most suits the content. We read the captions and select the one that is most likely caption of the field that contains the invoice number. This document, only the caption invoice can be associated with the invoice number. To find the number, we will rely on the caption of the field. First, we must define the approximate area of the invoice where to look for the number. On this document, there are several text objects in the vicinity of the word invoice. And most likely, the invoice number is the text object that is closest to the word invoice. So let us examine the text objects around the word invoice in a greater details. So first, to the right, there are digits 13, 69, 8, so they are positioned on the same line with the word invoice. Next, further to the right and slightly above the line, we can see the string ID 2589. This is the furthest object of all. Next, below there are words company best wishes come. If there are many alternatives inside the search area, we must make a choice. Select the object that most likely represents the number of the invoice. Typically, the invoice number is a set of digits or a set of digits and letters. An invoice number cannot be represented by a barcode or by picture. On this invoice, the number consists entirely of the digits. So next, let us examine the alternatives we have found in the search area. First alternative is digits 13, 69, 8. This is the most likely candidate for the invoice number, and it best fits the criteria described above. Next, the second alternative is the string ID 2589. This is most likely the some other type of the data, where ID is the caption of the field and the digits 2589 are contents of the field. This alternative is the furthest of all from the caption. We can discard this alternative because neither the type of content nor its position match the criteria. The third alternative is the string company best wishes co. This is not the number of invoice, but the name of the company. The word company is the caption of a field, and the words best wishes co are the contents of the field. Next, the digits 13698 are the contents of the invoice number field. It takes humans just a second to analyze an invoice in this manner. However, the above process is the most natural and simple way to describe the structure of the document. Unnecessary data can be detected by analyzing and describing the objects on the document. So, we have described a method for detecting data on a semi-structured and unstructured document. This is the same approach that is used by humans when looking for information on document. To enable a computer program to do the same, we must describe the objects contained in a document. In other words, we must formally state what we need to find and where it's likely to be found. So first, what? We need to specify the type of the object to find and their properties. In other words, whether it's a text string, a black line, a picture, etc. We analyze a document to see what kinds of the objects it contains, how they are positioned relative to one another, etc. This information can correctly describe the objects to enable program to detect them. The most precise our specification, the greater the chances that program will find the necessary data. First, we must define the type of the object we are looking for. Is it a picture, a text, a barcode, or something else? Then we should give more specifics. If we are looking for a particular text string, e.g. caption, we should state the exact text string. And if we are looking for an unknown text string, we should at least state the alphabetic characters that can make up the text string. If we are looking for a picture, we should state its possible sizes and specify other properties which may help the program to find it. Very often there will be more than one object in this search area, and the program will need to know how to choose the best match. In ABBYY FlexiLayout Studio, search criteria for objects are specified by means of the elements. A separate element is created for each object or group of objects that we need to find. First, we specify the type of the element, state the type of the object. Then we specify the properties of the element and define the area where the object is most likely to be found. We can have simple elements corresponding to objects like a text string, a data or barcode, and compound element consisting of several simple elements grouped together. The elements of a FlexiLayout are created one by one and are arranged in a tree-like structure. When the program applies the FlexiLayout to a document, it looks for the objects in exactly the same order in which the elements are arranged in a tree of elements, from the top to bottom. Our next task is where. We need to specify the search area where the data most likely to be found. For example, the required data may be positioned to the right, to the left, beneath or above the caption, or any other object which has already been described to the program. or the data can be positioned closest of all to a document boundary or some other data. A correctly defined search area will reduce the number of alternatives and save the program from need to examine and compare too many objects. A search area for elements is defined by a set of search constraints and relations. It tells the program where to look for the object described by elements. Search areas are made up of one or multiple rectangles. Search area may be defined by absolute search constraints, let's say by coordinates, or by relative search constraints, let's say by relations to other elements. When specifying relative search constraints, you can use any elements located above and described element in the FlexiLayout tree. The image object corresponding to this element can only be found by using information about the already found objects described by the elements higher up in the tree. So, how can we specify the absolute coordinates of the search area? For multi-page document, you can select a range of pages on which to search for an element. You can specify the absolute local coordinates of a search area in element property. Also, it's possible to exclude from the search area the region of the already found element. If no excluded elements were found, the constraint will not affect the search area of the element. And to define a relative search area, we need to specify a reference element relative to which the boundaries will be defined, and specify the relation of types right of, left of, above and below. You can specify any number of search areas for any element. The boundaries of the search area may specify it relative to different reference elements. And if no relative search area has been specified, the program will look for the object everywhere on the image. Each of search constraints specifies a health plane. The intersections of health plane and the image produces a rectangular part of the search area. The intersection of all the search constraints with the image produces the search area for an element. And you can also specify the search constraints in a special FlexiLayout language. Before you start describing objects, you need to find out what types of objects the documents contain, and if they contain a text object, it's helpful to know the actual text strings. To find this out, you need to pre-recognize your images. As a result, program will detect objects, identify their types, and recognize text on the text objects. This is important because you need to know how the program recognizes a word in order to formulate the right search criteria for the corresponding objects. The speed and the quality of recognition also depends on the type of the image with which the program is working: color, grayscale, or black and white. Black and white images are smaller than color images and faster to process. However, if the quality of the scans is not very good, the color and grayscale images preserve more useful information. Pre-recognition is the first stage of processing semi-structured document. Unlike the structured forms, which are designed with a computer processing in mind, unstructured documents have different structure and data fields are placed in different parts of page. For this reason, pre-recognition is used to detect the objects on the document which should signal the location of the data fields. FlexiLayout Studio allows you to create descriptions of documents with tables, including the tables on financial documents. More generally, the program can be used to describe any data that have a table-like structure. even if there are no explicit grid lines. Tables may spread over several pages, starting and ending everywhere on the page. For the purposes of creating FlexiLayout, a table can be divided into three logical parts: a header, body, and a footer. The body of a table contains the data that must be recognized and extracted. The header and footer function as the top and the bottom boundaries of the body. Additionally, the header contains the names of the columns. This information is used by a program to correctly divide the table into columns. The program detects cells by relying on the black separator lines and white gaps, which may divide the table into columns and rows. Also, FlexiLayout Studio allows you to create a FlexiLayout for multi-page documents. The program will treat the document as one whole and look for the elements irrespective of the pages on which they are located. In the FlexiLayout properties, you have to specify the minimum and the maximum possible numbers of pages in the document. To detect the beginning and the end of the document, the use of special header and the footer elements is recommended. These are compound elements and must be placed at the beginning of the branch of the elements. A very important part of the developing process and searching elements is analyzing and modifying hypotheses. A hypothesis is an assumption made by the program that the detected object corresponds to a particular element, that it meets properties and search criteria specified for the element. There may be several objects or sets of objects in the element search area, all of which correspond to the element. In this case, the program will formulate a hypothesis for each detected object. And hypotheses are characterized by their quality. The quality of hypothesis measures how well the detected object matches the description contained in the corresponding element and its numerical value from 0 to 1. The quality of hypothesis is calculated as pre-search quality multiplied by post-search quality, where the pre-search quality is the quality of the settings made in the properties dialog box and in advanced pre-search relations field. For the post-search quality, actually it's a result of applying the conditions specified in the advanced post-search relations field. So the quality of hypothesis for a group element is calculated by multiplying the qualities of the hypothesis for all constituent elements. For optional element, the program formulates a null hypothesis. Null hypothesis is a hypothesis which the program formulates of it has detected no object corresponding to an optional element in the search area. This means that if program does not find any objects corresponding to an optional element, it doesn't stop matching the FlexiLayout, but formulates a null hypothesis and assigns its quality set by the user when creating an optional element. Sometimes you may encounter documents with identical set of parameters, identical rules, and written in the same language, but with element positions varying greatly from one document to another. In this case, you may create a FlexiLayout that includes several alternative layouts, each layout corresponding to a particular subset of documents with identically positioned elements. Apart from the layouts, the other processing parameters such as pre-recognition languages, rules, number of pages, etc. Will remain the same for all such documents described by the FlexiLayout. The FlexiLayout alternatives are specified as separate branches in the tree of elements. Instead of one group element, by default it's named search elements, you can create several elements, each having its own layout alternative, which is represented by a branch of elements that describe one particular subset of documents. The layout alternatives are independent and elements in one branch should not refer to elements in other branch. And the names of the layout alternatives should be unique. So we recommend selecting descriptive names that reflect the nature of a corresponding subset of documents. When matching the FlexiLayout, program will apply layout alternatives one by one from top to the bottom. If more than one layout alternative match a document, the first match will be used. And the image areas are specified for the blocks in each layout alternative. The FlexiLayout Studio provides nice tools for advanced users. It's possible to specify the element properties, relations between elements, and set of additional constraints with a special FlexiLayout language. The search constraints can be specified for each element in the FlexiLayout language on the Advanced tab of Element Properties dialog. The optional search constraints can be of two types. Advanced pre-search relations that modifies the element properties and search conditions, and advanced post-search relations to select and modify the generated hypothesis. Also, the block area can be programmatically set up and adjusted. FlexiLayout language provides a lower level of settings and extend the basic graphical functionality of the FlexiLayout Studio. After all setting up, when the FlexiLayout has been debugged, it should be exported to a file in order to use it by FlexiCapture. When you select Export command in ABBYY FlexiLayout Studio, the program creates an AFL file which stores information about the elements, blocks, and their search conditions. In ABBYY FlexiCapture, this FlexiLayout is added to the document definition. When you export a FlexiLayout file, the program will automatically check the FlexiLayout for any errors in elements, block properties, search areas, etc. ABBYY FlexiCapture Engine can process fixed forms and flexible documents within FlexiCapture 10 projects. To use this functionality, first you must create a project with the help of ABBYY FlexiCapture and then use it in the engine. The quickest way to start using FlexiCapture 10 is to read through the help file and look at the sample code that comes with the software. It now features a comprehensive set of code samples that explain various aspects of programming with the SDK. Each library section contains one or several code snippets escorted by step-by-step description how to perform the task. This sample presents simple viewer for FlexiCapture project. It shows how to create your own visual representations for FlexiCapture Engine objects. The sample displays the FlexiCapture project and allows you to view its properties and properties of particular batches and fields. After this slide, I would like to show you a short demo how we can use the FlexiLayouts in your application. So here you can see the interface of FlexiLayout Studio, which is divided into three windows: batch view, layout tree structure, and image preview. Let's look through uploaded images. These are the invoices from different companies. Page layout is not the same, as you can see. For this demo, I have already prepared the FlexiLayout project and all required fields are already described. As you see, group of blocks will already contain all fields on the document, and locations of these fields are highlighted on the picture. Let's switch to the elements view. So elements are highlighted with a blue color, and you can easily see the visual difference from the blocks. It's very easy to verify if elements were found on every page of the sample images. And our FlexiLayout project is ready and we can export it. The result will be compiled to AFL format. The next step is to add it to our document definition. The prepared project could be used inside your application. For a demo, I will upload the project without any changes to a standard sample. The sample visual components is supplied together with a FlexiCapture Engine, and you can run compiled version or get the source code to modify application according to your needs. And this sample is a simple data capture application with a graphical user interface, and it's constructed from ABBYY FlexiCapture Engine visual components. The sample includes tools for work with FlexiCapture project, and you can view the project, load new images. So let's look how it works. So from the file menu, I have to select the Open FlexiCapture project item and select Prepared project. My project has a batch with the images, but we can also add new images manually. So I press this button to recognize my images. So you can see a result. All fields were successfully found and data were extracted. Let's look through these fields. You can verify the recognized data by clicking Verify button. So here we can see the context verification. And on clicking Export, we can export our results according to the project settings. As you see, with the ABBYY FlexiCapture Engine, you can quickly develop solutions for extracting data from the forms and documents, or of virtually any type or complexity. So actually, that's all that I had to tell you. Thank you for attention.